Welcome back to Q-SYS network training. Now, in this section, we're going to learn about the key technologies of Q-SYS as they relate to the network. And it all comes together in something called Q-LAN. So Q-LAN is our name for all of the technologies that we use to deliver audio, video, as you can see, synchronization here as well as a lot of other things that we'll get into later on. And what I'd like to do first is talk a little bit about the audio and the video routing using Q-LAN and what that really means, particularly in terms of latency. Because Q-SYS is not designed to be a system where you get audio, but maybe it's slightly out of sync and it doesn't really matter. It's meant to be seen as a completely real-time audio system, just as if it was one system or one product, even though it can actually be over a gigantic network. So what you can see here is a few bits and pieces. Here we've got a audio output. Over here we've got an audio input, and there we have our Q-SYS core, our Q-SYS processor. So let's say we've got an analog input coming in. That's going into one of our peripherals there. What that's going to do is it's going to go to the core. So first thing you need to understand is that all the audio in Q-SYS always goes to the core before it goes to its output destination. Then it's going to go to the output, okay? And then it's going to go maybe analog or maybe some other format onto its next destination. And these blue lines here, that is the part that's happening on the network. Now this entire path, including all the processing, is around roughly 2.5 milliseconds. So really, really short latency. For context, audio in the air is about 1 foot per millisecond. So 2.5 milliseconds, it's like you're standing about 2.5 feet away from the loudspeaker. So it's not a long amount of time in audio terms. But let's break that down just a little bit, okay? So if we look at the travel on the network, it's a really short amount of time, okay? It's around 0.3 milliseconds, around 1/3 of a millisecond to get from any network source to any network destination. And the core processing, it's around 2 milliseconds, slightly less. And that includes actually delay buffers, so that audio coming in from all sorts of different sources with different latency times actually all comes out completely in sync. Okay, so that's Q-SYS audio, and the bit we're going to be concerned about is this 0.3 milliseconds. We're going to talk later on about how we can really guarantee that that's going to work completely consistently. What about video? Well, with video, it's kind of similar, but a little bit different, okay? So same thing, we've got inputs and outputs, and we've got the core there. With video, it goes directly from the source to the destination, but all of that is controlled by the Q-SYS processor, controlled by the Q-SYS core. Okay? It's kind of orchestrated in terms of senders and receivers. And the reason for that is, of course, if we were going to send all of our video to the core, that would be a lot of traffic because, as you can imagine, video is quite a bit higher bandwidth than audio. Now, let's talk latency again. Basically, the total latency here from encoder to decoder, including the actual encoding and decoding, is around 2 frames. And for context, 1 frame is around 16 milliseconds if it's 60 frames per second. So quite a bit longer than audio, although still reasonably fast. Okay? But we'll see later the bandwidth could be significantly higher for video, and that's something we need to be thinking about. Lastly, we also said that Q-LAN is completely synchronized. And what we mean by that is that we're not sending these things over the network and kind of hoping they get there in the right time and playing them out when they arrive. Actually, we synchronize everything to a ridiculous degree of precision using something called precision time protocol. So here you can see a bunch of different peripherals. They might be audio peripherals, they might be video peripherals, and we have the Q-SYS core. And what that is doing is it's really synchronizing them all with nanosecond precision. Okay? So that means that we could play audio from any source to any destination or multiple destinations, and even if they all have different latency paths across the network, it will all be played out at exactly the same time, which is really what you need from a real-time audio and video system. Now, in the next section, we're going to have a little look at what Q-SYS actually needs. So we've talked about what it's going to do, but what does it actually need from the network in order to achieve this? Well, 2 of the most important things here are going to be speed and consistency. Okay? Speed because of what we just saw, we've got that quite tight latency requirement, but also consistency. Even if that latency requirement is always quite short, we don't want it changing and shrinking as different traffic occurs on the network. Now, a nice way to look at a kind of analogy of this is to actually look at technology that's probably quite familiar to you IT professionals out there, something like VoIP, which of course is also another audio over IP protocol, but it's a little bit different. And I've put together this little analogy to help us understand this, okay? Here you've got boxes coming through the factory, and think of each box as an audio packet, okay? Now with VoIP, we've got a pallet there. We've got a buffer that allows for these to all be assembled before they're taken away. And what that means is that it doesn't really matter if some of them are late, some of them are early, as long as they all get there in time for the truck that's going to take them away. Okay? Let's just take another look at that. So we're moving the boxes onto the pallet. We could have late ones, we could have early ones, as long as they arrive in time for essentially the receiving device to take that pallet and process it, we're okay. All right? So we have a buffer that accommodates these late packets. Now, that's slightly different to something like Q-LAN or other AV over IP protocols. So let's have a look at Q-LAN here. There's no real buffer, which means super low latency, but it means that every packet gets collected as it comes in, okay? And as you're about to see, if we get the truck appearing ready for the next packet and it's not there, well, now you've got an audio dropout, okay? Now you've got nothing. And if that packet then does arrive, it's not going to get picked up because it's late. It's now irrelevant because we have that really tight synchronization. We're always playing out the packets at the right time, okay? So the benefit to this is that we have this really, really low latency, but it does mean that we need to ensure a lot of consistency. Otherwise, we're going to have late packets which become useless packets, all right? So just to summarize that, with VoIP, we're looking at around a 20 milliseconds latency tolerance. As long as our packets arrive within that kind of tolerance, we're going to be completely fine. But with Q-SYS, it's going to be, as we saw earlier, around 0.3 milliseconds, which is a difference of 66 times, okay? I had a calculator, I did some maths, I checked, all right? So what we've just seen there addresses the need for speed, but what about consistency? Why is that so important? Well, this is where we're going to start to get into PTP, Precision Time Protocol, and how that works to synchronize the whole system, okay? So what you can see here is we have our Q-SYS core and we have a peripheral, and we're going to see how PTP works. Essentially, in PTP, you start with a clock leader, called the clock leader because it's actually going to be sending out the current time. It's going to send that to a peripheral device, okay? And that peripheral device is going to respond. It's going to ask for a delay request, all right? It's going to send this delay request back up to the clock leader, and the clock leader is then going to send a delay response. And that is essentially the time at which the delay request was received. Now, the important thing here is not actually all the detail of how all these packets communicate with each other and how this works. If you really want to find out exactly how it works, go and look on Wikipedia. That's what I did. There's a very nice diagram that explains it all really, really well. The important outcome is that it means that the actual offset, the timing offset between these devices, is going to be calculated to a pretty ridiculous degree of precision, okay? Sub-nanosecond precision, but of course this requires a consistent offset. If you have utilization on the network changing quite a lot and you've got more bandwidth and less bandwidth, you're going to find that the actual timing offset between devices increases and decreases. We call this jitter. Even if the latency is still within limits, we're going to find that that is going to cause problems with synchronization. And we'll address that in a later part of the training. All right. For now, just take a little break and I'll see you on the next one.